Good morning, sir. This is Abhishek. Am I audible?
Good morning, sir. Again, welcome, sir. I am audible to you, Abhishek, sir?
Yeah, you are audible to me. Sir has, sir has done the audio off. That's why, I guess.
Okay.
Yeah. Okay. Now it's on. Yeah. It's
Good,
on. Yeah.
good morning, sir. Good morning, sir.
Good.
Abhishek, this side, sir.
Good morning, Abhishek. How are you?
Thank you. I'm fine, sir. Thank you so much.
It's a good thing. Yeah. Thank you for putting me in.
Thank you.
So with permission of sir, shall we start?
Yeah.
Oh, yeah, definitely. How do I share my screen on this? I have got this screen share option. That is chat.
Okay. So once again, welcome you all.
Yeah, I think I should be able to share the screen. Yeah, just give me a second. I will just find out how do I share my screen.
Just I introduce you in front of our participants, sir.
Yeah.
Yeah. So once again,
Yeah, just give me 1 second. I will just find out where is my, how do I share my screen? Then after that, yeah, you can introduce me so that I can take it on from there.
sure, sir.
Where is it? Present now, more options, change the layout full screen. A window, multi-screen. No, that's no good. Where is my PowerPoint? That's here.
So meanwhile, I wish to introduce our experts. Once again, all of you in this TechCube 3rd sponsored 1 week STTP on artificial intelligence and machine learning. We have it, that is the day 6, session 2. We have with us expert Professor Sreenatha, Gopalarao, Anavatti, sir. Former Professor IIT Bombay, Senior Lecturer, University of New South Wales, Australia. It is our honors and privilege for me to welcome you, sir, in this TechCube 3rd sponsored 1 week STTP on artificial intelligence and machine learning, organized by Department of CSE, Engineering College, Banswara. Now I'm going to briefly introduce our expert. Sir was assistant professor 1991 to 1997 at Indian Institute of Technology, Bombay, and associate professor 1997 to 1998 in Indian Institute of Technology, Bombay. Lecturer from 1998 to 2001 and senior lecturer from 2001 to at University of New South Wales, ADFA campus, Australia. In this position, sir have taught in flight mechanics, flight control system, missiles guidance, spacecraft dynamics, orbit mechanics, classical and modern control theory. In the research experience, sir having application of fuzzy logics and neural networks for aerospace applications like wing rocks, attitude control for flexible spacecraft, control of flexible robotics arms, design and analysis of robust autopilots for aircraft and missiles. Sir, having consulting interest in flight dynamics, design of autopilots for aircraft and missiles, flexible spacecraft dynamics and control, active vibration control, application of fuzzy and neural networks for practical applications, and many more. Sir, having vast teaching experience, having lots of publication in national, international journals and conference papers. Once again, welcome you, sir, for giving you a valuable time to us in your busy schedule to share your expertise with us and our participants. Once again, welcome you, sir.
Thank you very much for that. It's nice of you. Guys, can you all hear me?
Yes, sir.
Fantastic. Okay.
Yes,
I'll try to share my screen. I'm not able to do that. Let me see once again. Share. Yeah, can you see my screen?
Yes, sir, it is getting visible.
Sir.
Perfect. Okay, so that's good. Okay, so before we go on, as I was introduced, yeah, I was with IIT Bombay for about 7 years before moving on to UNSW at Canberra. UNSW at Canberra is basically a defense collaboration college between defense and the University of New South Wales. So we teach mostly the defense students for their undergraduate program, but for masters and PhD programs, we can get students from anywhere all over the world. And I have been lucky to supervise nearly more than 20 PhD students in the last few years. As it was indicated, basically I have got quite a lot of interest in terms of intelligent control, and we do quite a lot of work in terms of autonomous vehicles, which include ground vehicles, underwater vehicles, as well as aerial vehicles. But my main specialization in terms of aerial vehicles, which are related to the UAVs, but I have also done some work in terms of ground vehicles as well as the underwater vehicles. So in the examples, so possibly I will show you one example of ground vehicle, one example of underwater vehicle, and one example of the aerial vehicle. All right. So before we go on, another informal question. What do you think about the cricket test between Australia and India? What's happening? All of you are watching it? So all of you are watching the cricket match between India and Australia?
Uh,
Yeah.
Yes,
Not
sir. Yes,
really.
sir. Yes, sir. We have been watching, sir.
So what do you think is going to happen?
if injury, I mean, won't get happen, sir, then something will happen for us. I mean, for Indian perspective. Yeah.
Okay. All right. Yeah, it's an interesting stage, but we have lost already. Like India has already lost 2 wickets,
Yes, sir.
but it is raining, so hopefully it should be all okay. Because yeah, I do have a lot of interest in cricket. That's the reason why I asked you before I
Yeah.
start.
Yeah. Yes, sir.
Perfect. Okay, so what we'll do is we will start with my presentation, so that after that we'll see like if I can take some questions from you people and then try to answer some of them. And the questions need not be related to this area. You can ask me questions in any area that you have interest. If I can answer, I will try to answer. If not, I will indicate to you saying that I will try to get an answer and then come back to you guys. All right. And just keep it open. So like keep your mind open once again. Okay. So it's not, I haven't structured the presentation in such a way that it has to be a very high quality technical presentation, but generally it has got some ideas about what are fuzzy systems, what are neural networks, and then how do we use them in different applications. All right. I have titled my presentation as Path Planning and Intelligent Control for Autonomous Vehicles. And why did I put path planning and why did I put intelligent control? So any control system, as all of you know, need to have some guidance command, or a command has to be there for the control system to work. All right. And when we talk about the autonomous vehicles, so this command has to come from inside the vehicle itself. The vehicle should be able to generate the command, so that then it is not getting any input from outside like a human being. So when we talk about the autonomous vehicles, we are trying to talk about intelligent vehicles which can command themselves and do those operations that are required from the vehicles. So when those commands need to be generated, so one of the ways that they are generated is using what is known as path planning. And in terms of when we talk about autonomous vehicles, so like when we talk about the vehicles, they are something which can move from place to place. All right. So when they are moving from place to place, so we are looking at a path that they take from point to point. So that's where we are looking at it in terms of the path planning. So this path planning provides the command to the autonomous vehicles through the intelligent control that is there, from which they are executed, and the actuators basically use that information to drive the autonomous vehicles. before I go, can you all, is the speed that I'm speaking, is that all right? Or you want me to slow down? You want me to speed up?
So we will let you know, sir. It's okay for us.
Okay,
For now.
sir.
Yeah.
All right. Cheers.
Go ahead.
Okay. So when we talk about this path planning, as I indicated, so basically it is just navigation. So, and as human beings, everything like that we do is based on the navigation that we are trying to do, or the path planning, which is what we are trying to do. All right. So this path planning for the autonomous vehicles is actual path, but for any other operation is equivalent of path planning. So when you are when you came for this course, so you had an indication to say that this is what I want to learn. All right. So that's what I want to learn is basically the path that you are trying to look at, so that you can improve your career, so you can improve your research caliber, so you can get some ideas. So which is what basically the thinking process that has gone before you came to this course is what we are looking at it as the path planning. So it is not really the path in terms of the actual vehicle. But when we talk about the autonomous vehicles, realistically, yeah, we are looking at the path itself. And when we look at this path, in general, what happens is we always come across obstacles, because there is nothing that is achievable in this world without any obstructions. Is that true? Have all of you got everything without any obstacles in your way? Have you been able to achieve what all that you want without any obstacles?
No, sir. No, sir.
Yeah, definitely. When we look at those obstacles, so we look at those obstacles as static obstacles and dynamic obstacles. So these static obstacles are something which we already know that they are there. So we need to find a way of overcoming them. So like when you wrote your examination, you knew that you had to write your examination, right? So you prepared for that examination. So that was a known obstacle that was there on your path. So that becomes something like a static obstacle that you have got, all right? But in addition to that, there are dynamic obstacles as well. So you prepared for the exam thinking that this is what is going to be asked. But when you went there, you realize that the questions are not what you were expecting. All right. So you have to modify the thinking process to ensure that you'll be able to overcome those questions as well. So they became something like dynamic obstacles that you have got in your system. All right. So it doesn't matter what process it is. We always have some obstacles which are known to us for which we can plan. And there are some obstacles for which we can't really plan well in the beginning. So we need to plan for those dynamic obstacles as and when we see them. So if we can do that, so if we can find a way of overcoming those obstacles as and when they come, so then we become intelligent. Is that true? So anybody who can overcome the dynamic obstacles is the most intelligent person. Is that
Yes,
true?
sir. Yes, sir.
Yeah, perfect. So, and when we talk about this path planning, so in terms of general path planning, normally we talk about them in terms of heuristic path planning and optimum path planning. When it is heuristic, somehow you find a way of doing your job. You are not worried about how you did your job. You wanted to ensure that the job is done for you, all right? And that's how most of us work. But there are some people who are very smart. So what they do is they find an optimum way of overcoming these obstacles. Those who can plan very well in advance and start looking at an optimum way of doing it, they are probably better. It doesn't mean that the heuristic people are bad, but heuristic people probably are much smarter because they can come out with shorter ways of trying to ensure that they can overcome these obstacles. And in terms of dynamic obstacles for the vehicles per se, so we try to use a sensor to identify the obstacles. So like when we are as a human being, we try to look at the obstacles in terms of the eyes that we have got, the ears that we have got, or the sensory system that we have got. So that using these sensors, we are able to identify. Sorry guys, I haven't put you to sleep already. So we try to identify these obstacles using the sensors that we have got. All right. And in terms of the vehicles, we try to use TOF cameras or 3D sensors. We use optic flow techniques, laser sensors. So we try to use that information from these sensors. What do? We try to predict what is likely to happen. And if that prediction is good, then what I can do is I can rely on that prediction to ensure that my controller is capable of trying to overcome those predictions. So if that is what we can do, then we are trying to say that we are able to learn from the environment that we have got. And once we can start learning from the environment that we have got, that is where we have got the option when to learn, we become intelligent. So everybody can learn, but when to learn is something that's very intelligent, which is what somebody makes it as a intelligent controller. So I'll try to give you an example to say that when to learn a little later once again, all right? And when we talk about this intelligent control, so basically it is the brain of the autonomous vehicle, because intelligent control is something which is similar to the brain that we have got as human beings, because it takes the information from outside using the sensors. So that means you know the dynamics of the environment that you are in there. Then you try to do the thinking process using that information and try to act based on that information, so that you are using your actuators to ensure that whatever that is there in front of you, basically you are able to handle that. So that's the reason why we call these intelligent controllers as the brain of the autonomous vehicles. So what we want them is this brain that is there, it should be adaptive and it should be evolving. And when you say adaptive, so there is a subtle distinction between adaptiveness and evolution. So when we say adaptive, so you have got a certain process so that you will be able to use that information to change yourself. So you don't change the structure that you have got for your thinking process. All right. So you have gone through your engineering. So let us say somebody has done a mechanical engineering degree. So what he can do is he can use all that they have learned in terms of mechanical engineering degree to the situation that they have got, so that they can adapt themselves to the situation that is there around them using the process that they have learned. So the structure of thinking hasn't changed. But there is another set of people who can evolve. So many of the mechanical engineers, they can move on after a little while to become, say, like aerospace engineers, or they can move on to become, say, like managers, or they can become something else. So when they start evolving with respect to time based on the system that they have got, they are considered to be more intelligent than the adaptive ones. So this evolution is the one that brings in the intelligence. So which is trying to say like learn as we go. So for this, basically we try to use the fuzzy and neural controllers, because we have seen that, like, as I know, they are definitely better than rule-based systems, are the generally what earlier times used to be called as just artificial intelligence, just simply based on the rules. All right, so just to give an introduction to fuzzy systems, I have got a paradox here. A barber advertises his services with the logo, "I shave all, and only those men who don't shave themselves." So what is right with this advertisement? What is wrong with this advertisement? What happens if he has to shave himself? Can any of you tell me what happens if he has to shave himself? So can he shave himself? It says, the logic says, I shave all and only those men who don't shave themselves. So when the barber advertises his services, he thought that he has come out with a very fantastic way of advertising what he wanted to do. And if he wants to stick on to that rules, then if he has to shave himself, then there is no way that he can do it, because if he has to shave himself, then he can't shave him, because he has to shave only those people who don't shave themselves, right?
Yes, sir.
And if he doesn't shave himself, so that becomes he becomes a guy who doesn't shave himself, so he has to shave him. So that becomes a contradictory logic. So the logic is basically something which is not very well defined in this case. So similarly, does a liar from Crete, it can be anywhere else, lie when he says that all Cretans are liars? So do we believe his statement or not? If we believe his statement, then Cretans are not liars, because he is not telling a lie. If we don't believe his statement, what is going to happen? Once again, we have a problem. So these types of logics, they keep coming up in our standard life, which we call as paradox. So the normal logic doesn't solve these ones. So if we are trying to use simple artificial intelligence, quite likely that we may land up with a problem with these types of problems. So that's the reason why fuzzy systems came into picture, so that you can draw, instead of a hard boundary, you can have a soft boundary between the logics that you have got. And once you can use the soft boundary, then depending upon the situation, you can move to the left, right, or the center. So that's where the advantage of the fuzzy system comes into picture, which is all what human beings use. So all the human beings use simply the fuzzy system for everything that we do. All right.
Yes, sir.
So the basic definition from, say, like a dictionary is, when we say fuzzy, it is basically vagueness, which also means that it is not crisp, because as human beings, we are never crisp. We are always vague. For everything that we do, we are always very vague. But depending upon the situation, somebody else tries to interpret that vagueness into something that they understand and then use that. That is where realistically many times communication gaps come into picture, because we are not very crisp in what we are trying to say. Somebody else can take it in a positive way or a negative way. So that vagueness is something which is there. But that is part of the life. So that's how human beings always work. We always work with vagueness. We never work with crispness. But all the controllers that you people have learned anywhere, they work on crisp signals from the sensors, because the signal from any actual sensor that is there, say like a voltmeter or a ammeter or a speedometer, so they give you basically crisp readings to say that, okay, this is exactly what I have got. If you have got a thermometer, it tells you it is 32.5 degrees, right? It doesn't tell you that it is maybe between 30 to 35 degrees. So you don't have that vagueness when you look at the sensors. But when we look at as a human being, so if I try to touch somebody to find out whether they have got fever or not, I say approximately he may have a little bit of fever. So which is a vagueness that I'm trying to put in to say that his temperature may be a little bit more than the normal temperature. So when I say that I have enough money, so that enough money is something what I define. So that I define it as, I can eat my food, I should be able to pay my rent, I should be able to use my vehicle. For somebody else, that enough, he is just barely managing himself. He doesn't have money to come out with us to a hotel or a restaurant. So that vagueness is something which is what we have got in our human system. So which is what we use for the fuzzy systems. All right. So in general, a fuzzy system basically tries to take a crisp input, then it does what is known as a fuzzification. So that fuzzification is, we add vagueness to any input that we get. So that vagueness is done using what are known as fuzzy membership functions. So using that, then we try to infer based on the fuzzy rules. So these fuzzy rules are similar to the AI rules, which are in terms of premise and consequence. If I have money, I will go and eat food outside. If I feel hungry, I am going to eat today. If I feel tired, I am going to sleep. So that if basically is what we are trying to create the premise around which, and then the consequent is basically what the action that we are trying to do. So that inference is something which is very, very important in terms of the fuzzy systems. And as human beings, for everything we use these fuzzy rules. All of you agree with that? Is there anything that you do without an if and then?
Yes, sir.
Yeah, so that's basically what we are trying to look at in terms of the fuzzy rules. So that means any human rule that we have got is possible to be translated into the fuzzy system. So which gives a major advantage using the fuzzy systems. Then to just give that input or the inference that we have drawn, so we need to translate it into a crisp output. So we try to use what is known as a defuzzification. So a fuzzy system is simply consisting of a vagueness defining system, then you have got the rule based system, and then coming back to the de-vague, so that you are going to get a crisp output for your system. This can be used for formulating models. This can be used for control. So it can be used for both identification as well as control. And it can be used for anything that we have come across in our life. All right, so that's the reason why fuzzy systems have become very, very popular everywhere. You see that you have got fuzzy systems in your TVs now, you have got fuzzy systems in your camera, you have got fuzzy systems in your washing machines. So anywhere that you look at, you have got a fuzzy system there now. In terms of neural networks, the difference between fuzzy systems and neural networks is everything that we write in terms of fuzzy systems is in terms of the rules. So those rules are very important. But for many people, it is not very easy to define these rules. Whereas when we learned our mathematics, we never learned the rules. So this rule system came little later. So when in terms of the neural network, so what we try to do is we take the inputs, we try to do a lot of operations on them in some way mathematically to ensure that we get an output which is related to this input. So the idea of neural networks came into picture simply by what is known as the mapping theory. So what you can do is you can map the outputs to the inputs using some function. And as you make your function more and more complex, it becomes a more and more complex neural network. And the worst thing that is associated with these neural networks is logically it is very difficult to relate what the outputs are with respect to the inputs. They are simply based on the learning procedure in terms of these different lines that I have got there and the curves, which are basically known as the neurons that are sitting in there. All right. So in general, when we talk about the neural networks, so we have got two types of neural networks. And in fact, it is also true in terms of the fuzzy systems as well. One is known as the forward neural networks, where you take the input, you do a lot of operations, and then you get the output. So that is the end of the story. All right. So next time when you get a certain set of inputs, because you have done that process of thinking. So because what you have done is, if you train yourself so many times to say that, okay, if I keep writing like this, I'm going to become better. If I'm going to talk like this, I'm going to become better. So that process of thinking is what has been incorporated in these lines that are there between the input and the output, which creates that function mathematically. All right. But that is not good enough, because many times what happens is we also want to ensure that the output that is there has to be compared with the input that is there in some form, so that we can modify our thinking process. So that we need some form of feedback. So that feedback, once we start providing, you get into what are known as recursive neural network or recurrent neural networks. So most of the neural networks that you come across, either they are forward neural networks or the recurrent neural networks, but they are simply mathematical relations between the input and the output. And as you have got more neurons, as you have got more hidden layers, so it is simply you are trying to make the function more and more complex. Because simple function, if you are not able to ensure that the relationship between the output and the input can be mapped, then you try to make it complex. So you start with y is equal to x, then you say y is equal to x square plus something, y is equal to x cube plus 2x square plus 3x. So you keep on making that more and more complex. So that complexity is built in terms of the number of hidden layers and the number of neurons that you have got for your system. For a deep neural network, you have got now thousands and thousands of neurons if you want in the system. For a convolution neural network, you have got as many layers that you want in terms of the convolutions that you want for the system. So over the years, these neural networks, they simply started as simply a mathematical relationship. But then in 1986, so basically this MLP came into picture, multi-layer perceptron, where you have more number of layers, so that 10 neurons, so that you'll be able to get it. Then recursive neural networks came into picture, so that you can add the feedback. And that became, in fact, the most important addition in terms of the dynamic systems. Because when we talk about dynamic systems, what is happening today is based on the past. So that means there has to be a relationship between the past and the present. We should be able to predict what is happening today or tomorrow based on the past. That's what we are. So like if you are sitting in this course, so you are sitting in the course because you have done a proper degree in, say, like engineering. So you have done all your master's or PhD in engineering. So that's how you are sitting in here, all right? So if you had not been done those degrees, then you wouldn't have been sitting in this program at all. Because you are sitting in this program, so you are able to use this to extrapolate to improve your research quality or the teaching quality that you have got for yourself. So for all dynamic systems, this recurrent neural networks became a major advantage. Then over the years, now we have got deep neural networks, which is practically now it has become something like the what do you call that buzzword. So anybody you ask, they say that they are trying to use the deep neural networks, because the Google, Amazon, all of them, they try to use the deep neural networks because they have got enormous amount of processing capability. They have got enormous amount of data. So because of the big data analysis that they have got, so they can do the training for days together to ensure that they'll be able to learn the relationship between the input and the output. And that's what they are trying to use. And in addition, you also have got spiking neural networks. Then you have got evolutionary neural networks, so which is where additional intelligence comes into picture. And what these evolutionary neural networks do is they can change the number of neurons, they can change the number of neural layers or the hidden layers that they have got based on the conditions that they have got. So if you put some condition to say that, okay, under these conditions, I don't want these neurons to be there, or I want to forget about this, then that's where the evolutionary system comes into picture. All human beings are evolutionary because we can forget, we can learn, and sometimes if we scratch, we can go back and then relearn what we have learned earlier. So which is where the evolutionary neural networks comes into picture. All right. And when we talk about the fuzzy systems and the neural networks, so learning is something which is very important. So when we talk about the fuzzy systems, when we talk about the learning, it is basically in terms of trying to find a way of writing our rules. So one of the important ways is by what is known as supervised learning. So if there is an expert, he can write the rules for us. You have got a lecturer who has taught you how to do the work. Your teacher taught you how to do your basic mathematics. So your mom and dad taught you basically how to live. So that's basically what we call as the supervised learning. All right. But then you also have got the unsupervised learning. So what happens here is you learn something, but then at the end of the day, that's not good enough. So you also start learning by yourself. And also there are many tasks that you have learned by yourself without a help that is there available to you. So if you do that, then it becomes unsupervised learning. And the third category of learning basically is what is known as reinforcement learning, which is tactically we try to do it with all our kids, with all our students. So what we do is I'll tell the student, if you do well, you are going to get higher marks. And your employer says that if you do well, you are going to get a better salary or you are going to get a promotion. So we try to put a reward. And if somebody doesn't do well, we also put a punishment. So there is a reward either in terms of a positive reward or a negative reward. And based on that, we try to learn. So most of the autonomous vehicles, now we try to use this reinforcement learning so that they can learn by themselves. So that we try to reward them by saying that if you do a good job, okay, you can go ahead and do the job more. If you don't do a good job, then I'm going to punish you by saying that either I will take you off from the network, put some other guy who can do the job for us. So these are the three standard types of learning that is available both for fuzzy as well as the neural networks. So when we talk about this intelligent control, as I said, there are three processes that are involved. One is how to learn. The second one is what to learn. Third one is when to learn. So how to learn is something which is very easy because it is like there are a number of input data, there is a number of output data. So what you do is you try in using that. So like your dad has taught you to do some work, your mom has taught you to do some work, all right? That's based simply on the training because repetitively you keep doing the same thing. Then after a little while, then you can do it by yourself. It is like driving or learning to ride your bicycle. So you fell down quite a few times, but somebody held it around. But after a little while, you are capable of doing that. So you have been able to learn yourself. So that is basically what is known as the process of training. Then what to learn is something once again is based on the environment that you are in. So which is basically either data driven or batch training. So you have got different types of inputs, you have got different types of outputs. Based on your situation, you learn that. But the third one, when to learn, is something which is very important, which makes everything as intelligent or evolving. So if there are changes, we should be able to learn from those changes and then change ourselves. And who can do it much more quickly, then they become better in life. So that's how we are all right? So this intelligence, when we talk about the intelligence in terms of the controllers, this when to learn is something which is the most important one. And this when to learn basically comes from the path planning that we have got, which is the way of looking at the obstacles in front of us and overcoming those obstacles so that you'll be able to do the changes that you are looking to overcome those obstacles so that you can reach the target that you have got. It is like a football player trying to go from his side to the opposite side so that he can score the goal. So what he does is when he does, he knows where the goal post is. But in between, there are 11 players from the other side whom he has to overcome. So if somebody is very smart, so when you say like a football player is very good, so what he can do is he can dribble the ball to ensure that he can go around them and try to score the goal. So if he can do that, then it is a better way so that he becomes a better footballer. So that's where everything in terms of the intelligence comes into picture. And we call them as evolutionary controllers as well. So all intelligent controllers are evolutionary, as human beings are evolutionary. So I've got one or two examples here. So I have got a first example in terms of the ground vehicles here. So in the ground example, the first one that I have got here, so I have got static obstacles that are there, and I have got my vehicle here. So it is going through those static obstacles without hitting any one of them. And the command for that is generated through the path planning. And that command is passed to the neural network that is sitting into the robot that we have got there. So the ground vehicle basically has got a neural network controller, which uses the information that is coming out from the sensor. And that sensor tries to indicate that where are the obstacles that we have got on the path. And that is basically used to guide the vehicle. So in the second one that I have got here, so I have got a dynamic obstacle. So I have got my vehicle and I have got another vehicle which is coming on my way, which is what happens normally when we drive on the road or when you are walking. You keep coming across a lot of people and we don't go and crash into them. So what we do is we try to avoid them by going around them or slowing down. So that's basically what's happening in this case. So there is an obstacle in the way. So again, my controller can think of trying to overcome that by ensuring that it doesn't crash into that vehicle. So it's capable of doing that using the intelligent controller that is there. Then I have got here a underwater vehicle. So the experiment is a bit crude. So what we have done is we are trying to do this experiment in a lake that we have got in Canberra. So because we didn't want to lose this. So what we have done is we have tied a rope so that we don't lose it. But then this vehicle is supposed to ensure that it can do different types of maneuvers. And all that was done using the fuzzy controller that we have defined and put it into the system. Just show it. So it is supposed to do the dive in, it should be able to come up, then it should be able to pitch up or pitch down. So all that is basically done using the fuzzy controller. And because we didn't want to lose it, so we have tied it up with a rope. So somebody asked me that question, what happens if it had come towards you? We said, yeah, if it comes towards us, what can be done? We can't do much, right? And we also did some experiments in our swimming pool, which was a much better place, and a tank that we have got, which was much better. But then we also wanted to demonstrate that it can do these experiments in different environments or conditions. So we did these experiments in a lake there in Canberra. Okay, the last one that I have got here is the demonstration of an unmanned vehicle. I also have got for a rotary wing vehicle. So you can see this fixed wing vehicle, which is designed by us, and it has also got a fuzzy controller in that. So it is going from point to point A to point B, but in addition, it is also supposed to do few maneuvers. So you can see that it will do some, say like that's the upgoing maneuver. So it comes down. So it is like a sinusoidal curve that it's trying to follow.
Excuse me, sir. Sir, is
yeah.
this vehicle is under process? I mean, the work is still going on, or it is done, sir?
We have finished that. We are not really doing much work in terms of the fixed wing vehicle now, but
Okay, okay.
yeah, I do have that vehicle with me still in my lab.
Great.
Yeah,
So
yeah.
is there any limit, sir, I mean, is there any range that has been fixed before? I mean,
No, we didn't have any
okay.
range for that. The only range, sorry, yeah, we had
Yeah.
that because we were doing the experiments for one of our PhD students. We
Okay.
wanted to ensure that it is within the range for our remote control that was available, because we didn't want to lose the vehicle for some reason. So like there was a hands on and off possibility between the remote controller and the actual controller that is sitting in the system.
Yes, sir.
So when the vehicle took off, then we gave it to the controller that is there in the vehicle. So it did all those things. While landing, once again, we use the remote controller actually for that.
Okay, perfect. Okay, sir. Thank you.
Yeah. And this is the last one I will show you. So what I will do is maybe I will go back from here. Mhm. Okay. Just give me a second, guys.
Yes, sir. Sure.
Yeah. Okay. So what I will do is, uh, can you see this?
Yes.
The small vehicle, or you are still seeing my presentation?
We are saying your presentation, sir.
Okay, so I will go out from here, stop sharing this. Okay, that's where it is. Yeah, you can see this.
Yes, sir. It is getting visible.
I think
Okay,
that's all for the.
sorry.
Yes, sir. It is getting visible, sir.
Okay, that's good. Okay, so let me start from the beginning. So this is a small nano helicopter that we have got, where our defense is trying to use quite a lot of these nano ones now, so that they can use them in the number of swarms. So like you have got some 50 of them, 100 of them trying to do the job for us. So this is one of those vehicles which has got a neural network and a combination of neural network and fuzzy system into that, which is like a hybrid controller. And we are trying to ensure that it can do some monitoring around even in the presence of disturbances. So we created the disturbances in the lab using the fan. So I will start this and then put it onto the bigger screen. So you can see that it is trying to hold on to a particular position, which we call as the hovering. So it is trying to do the hovering in the presence of disturbances as well. So that means it is trying to learn from the disturbances and adopt the controllers, which is basically in terms of the neural networks and the fuzzy rules, so that it is able to still hold on to that particular place so that it can do some surveying, like surveillance for the vehicles. So as you can see there, the disturbances is basically coming from the fan, but it is a very, very small, tiny vehicle which can be put onto our palm. So it is basically a very small one. So normal condition, if you just take it and blow it a bit harder, then it will just fly away. But because of the controller that is there, it is trying to ensure that it can hold on to that particular position as well.
I think that's all for the battery. Turn
Okay,
it off.
perfect. Okay, that's where we are. I'll come back to my. All right, so that's where I am, and let me go back to my PowerPoint, the last one, just to show my PowerPoint. Okay, you can see my PowerPoint once again.
Yes, sir.
Yeah, slide from current slide. Okay, so that's basically what we are trying to work upon at this point of time. We are trying to do work in terms of autonomous ground vehicles. We are also doing some work in terms of autonomous underwater vehicles. And we are also doing work in terms of aerial vehicles. So in terms of the aerial vehicles, at this point of time, we are trying to do most of the work for rotary wing ones. We are not doing much work in terms of fixed wing ones. And for all of them, we use this fuzzy and neural networks. So if you look at most of the paper that I have got in terms of these control systems, they are either in terms of fuzzy or the neural networks, or a combination of them, all right? And out of that, this fuzzy is a bit more easier because it is easy to interpret. And the major advantage that I look from the fuzzy is you have got a lot of flexibility in terms of writing your rules, the way that you create your vagueness, the way you interpret the vagueness and then reinterpret the output. So you have got a lot of flexibility in terms of the fuzzy systems. And in fact, you don't require a lot of mathematics at all to learn about the fuzzy systems and put them into any system. So like if you have got Matlab, then you can go through fuzzy Matlab. You'll be able to write the rules, change the rules. You can do whatever that you want with that. But when you come to neural networks, they are a bit more mathematical. But the major advantage that you get with the neural networks is they are computationally much better, because you are simply doing addition and multiplication operations, whereas in terms of fuzzy systems, it's not straightforward. So you have to go through that process of interpreting the rules. So we do use neural networks sometimes, and we do use fuzzy systems for sometimes, but then we also use a combination of fuzzy and neural networks as well. And most of the work that we are trying to do at this point of time is in terms of the evolutionary fuzzy systems as well as evolutionary neural networks. And when I say evolutionary fuzzy system, so that means I can add new rules, I can delete old rules, I can modify the rules in any way that I want based on the input that is coming in. So there is no fixed structure for the fuzzy system. Similarly, in terms of neural networks, the work that we are doing basically incorporates that I can add any number of neurons, I can delete the neurons, I can recall the neurons, I can put them wherever I want. I can keep changing the number of layers that I want. So we do these modifications so that we get the best result, so that computationally it is much better and the accuracy is much higher. So that's the reason why we call these fuzzy and neural networks as intelligent controllers. So that's what I have got for you people. Thank you very much for listening to me. So
Thank you so very much, sir, for getting the time from your vacation. It's really
it's nice of you guys to ask me to do something, which is nice.
yes, sir. Thanks for your support, sir. I mean it.
Can we ask one question?
Definitely, I will. Yes, any number of questions, because I don't have to prepare.
We just wish to know about the learning algorithm you use for your experiment.
Yeah.
It was a super. Yes, please.
Sorry, once again, can you repeat that?
We simply wish to know about the learning algorithm you use for your experiment, sir.
Okay, the learning algorithms are written by us only. Most of those learning algorithms are heuristic in nature. So when I say heuristic in nature, so when I say that my accuracy is not very good, then I try to add more neurons to my system. If the accuracy falls down, then I say that, okay, I need to add additional rules so that I get finer replacement for my control input. And if once I start getting a good accuracy, then I start seeing that, okay, which neurons are not very good for me. So I can use, say, like distance criteria, I can use error criteria, I can use square of the error criteria. So we normally use error criteria, the square of the error criteria, so that we can use that absolute error, square of the error, and the error by itself, the three of them, to ensure that we combine them together to use this for the evolutionary systems.
Okay, thank you, sir. So once again, thank you in the whole fraternity of GECBANSWARA. You take a time from your vacation and share your knowledge with us, and it was very great pleasure to us that we have with you, and you are sharing your knowledge with us. So you are sharing path planning, and intelligence control for automation vehicles, intelligence control fuzzy systems, neural networks, fuzzy controllers, and lots more. Sir, from the behalf of GEC Banswara, we express our gratitude for sharing your insights and motivating the entire teaching fraternity, research scholar and students. Your support in this STTP was our strength, and we are looking forward to your collaborating with you, sir, in all our future academic endeavors.
Definitely will do that. No problem. Yeah.
Okay. So once again, thank you, sir. Thank you very much.
Thank you very much. Hey, any of the participants want to ask any questions?
So participants, please interact with the experts if you have any. Sir, one more question. We
Sure.
are so many scholars are there. What is the process for getting a PhD from out of the India, like your institute or somewhere else, for the scholars, sir?
Yeah, the only requirement that we have got in Australia, in our university is you need to have either TOEFL or IELTS. So if you have a good score and if you have got IELTS, because India is considered to be a non-English speaking country,
Yes.
so we need to have the IELTS score or the TOEFL score. And if you have got good academic record, perfectly fine. So you can apply. That's all. We don't require GRE.
Okay.
Yeah. So in fact, it is much easier to get it here than in America, but quite a lot of students come from different parts of the world now. It's not that, yeah, it's a bit competitive, but definitely it's much more easier to get it in Australia than in US.
Okay.
And the scholarship is much higher in Australia. I mean, the quality of life is much better in Australia. And most of the people who come here and do the PhD, they try to get their green card or similarly what we call as permanent residency here, so that you can take up a job here itself. So most of my students are here.
Okay, so I hope we will definitely try to do that. And thank you, sir, and also thank Professor Abhishek for bringing you with us. Without him, I cannot able to connect with you, sir.
Yeah.
Sir, actually, we are MTech batchmates, roommates
You
as
told
well.
me about it. That's
Yeah.
very good. Yeah. Very
So
nice.
that's why I requested you, and I'm so thankful to you, sir. Thank you so much.
Yeah, it's very nice of you guys. You take these initiatives to run different programs and try to give exposure to everybody around.
Yes, sir.
Because even to create these opportunities is not something which is very easy. You people have to spend a lot of time, effort in organizing these things, which is very good. Yeah,
Yes, sir. It has been done on a short notice, sir. That's why we have got some, response has been, less. Otherwise, we will cross over, more than 200 or 300 if we'll have some publicity part or something to be done. Yeah.
Fair. Yeah. As long as it is interested candidates, it doesn't matter how many
yes,
are
sir.
there.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So, thank you very much once again, sir.
Yeah. All right. Okay. Enjoy your day, guys.
Thank you, sir. Thank you.
Yeah. Stay safe. See you.
You too, sir. Thank you.
Bye-bye.
Bye,
Bye.
sir.
Bye, sir.
Bye-bye.
So, participants, this lecture was one of the former professor IIT Bombay and currently working in Australia. It was very great experience with us. And Professor Abhishek, shall we stop session over here or something else, sir? What do you think?
Whatever you will say, sir. I can, perform some examples of Matlab.
Sure, sir.
If they want.
Sure. Welcome. So now we have with Professor Abhishek Kumar, sir. So please, sir, welcome.
I told you that one of the program was not, got run at that day because of the version. So let me start with that program only. Is it visible, sir?
Yes, sir. Perfectly visible.
Okay, sir. So this is the program. I'm just increasing the size. If it is not visible to all of you. So one by one, I will do some basics example so that you can get connected with these things. So let's start with the program. I did that on that day, and let me present it again. So good morning, one and all. So this is the program and where we are getting the error is, so I'm just letting this program into bigger picture so that you can see everything. So this is the program we have discussed. So is it visible? This program is visible, Himanshu sir?
Yes, sir. Perfectly visible, sir.
Okay, I'm not able to see that, that's why. It's okay. So whenever it is not visible, so just let me know.
You can able to view your Word. Yes.
Yeah, Word file, and then this is, you able to view this MATLAB?
Yes,
Okay,
Matlab also.
okay, done.
Perfect.
So this is the program. So we just need to change something, that host.jpg or something. So we are supposed to do segmentation here. We are supposed to do filtration of red channel, blue channel and green channel over here. So there is a problem over here in this particular line. I'm just going to show you. This one, the line, which was having problem. Fine. So what we did is that particular image is not getting run. So we have taken a image which has been assigned some image before. So this is the case. Fine. So this is the line where we got the error. So now we can run this program and let's see what the output is. Apart from this, every other concepts has been discussed, that what is quantization. Fine. To convert gray image into 8-bit plane or 16-bit plane, or to reduce the resolution. Fine. Then there is a MATLAB command we have used called phantom. Fine. अब वो 8 into 8 से 64 into 64 करना हो तो आपको phantom command use करना पड़ता है, और शिप लोगन जो है वो algorithm है, वो inbuilt algorithm है. You just need to put the name in a single inverted comma and then it will get run. Fine. And you can name that particular image of 64-bit plane into a synthetic image. That's why I have used the title synthetic image. Fine. अब अगर आपको कोई बोले कि उसका सिर्फ ग्रे लेवल इमेज जो है वो डिस्प्ले कराओ, तो आप क्या करोगे? देन वी हैव टू यूज द कंसेप्ट ऑफ स्यूडो कलर. फाइन. देन स्यूडो कलर में जब आप कंसेप्ट यूज करोगे तो उसके अंदर आपको यूज करना पड़ेगा कलर मैप. ठीक है? तो कलर मैप जब आप यूज करते हो या फिर ऐसे लिखते हो, दिस इज बाय pseudo color using color map. So if you are writing the things like this means you want to display the pseudo color of the image. Fine. So whatever is getting subplotted at the 8th position, it will be a pseudo color image. So now we can see it. Just make it copy. We have changed the image color and we do have that. Even if we don't have, let's do this. Yeah, we have host.image. So I'm minimizing this. So you can see that we have a host.jpg. Fine. And then we are having this as an output, which can show everything in a very depicted manner. So we have to take a very, image which is having very good resolution with RGB constituent, then that will be subplotted in a contour as an original color image. Then there is a red channel. So this red channel is for colon space 1. When it is 2, when it is 3, then there is RGB. Fine. When we have to do the blue channel filtration, when we have to do the green channel filtration, then we have to generate the histogram for particular red channel actually, and then we have to convert the gray image into 8-bit plane. Finally, we have that particular 8-bit plane is getting resolution into 16 into 16. Fine. And finally, when we are performing quantization, So let's see what we have done in the quantization part. You will able to understand that what we have done in the quantization part. So we have done nothing. We have just used the concept of gray slice. I mean, whatever the reason we want to focus in, we just perform the command gray slice into it, fine. And we have turned that thing into sub image. I mean, image के अंदर sub image करना, यानी चीजों को quantized करना, sample करना, ठीक है? तो ये जो है आपका वो quantized हो गया, ठीक है? Suddenly you are using Python. Why we are using Python? To make that image synthetic. And what is the point of getting that image synthetic? तो अभी इसके बारे में अपन इतना ही देख सकते हैं कि जब आप कभी भी फैंटम कमांड यूज करते हो तो जो भी आपका इमेज है उसको अगर आप जितने भी रिजोल्यूशन में आप उसको मॉडिफाई करना चाहते हो, या वेदर इट इज 65, वेदर इट इज 32, वेदर इट इज यूनिट 16, वेदर इट इज यूनिट 32, आप वो सिंगल कोट में पास कर दो. दैट विल बी अ पैंथम कमांड फॉर यू. फाइन. फाइनली जब आप सब कुछ परफॉर्म कर लेते हो, देन देयर इज अ स्यूडो कलर कंसेप्ट. उसके लिए हमने क्या यूज करा? स्यूडो कलर के लिए हमने कलर मैप यूज करा है. कलर मैप और जेट. तो जैसे ही आपने कलर मैप और जेट यूज करा, आपको एग्जैक्टली पता चल रहा है रेड जो लाइन है वो कहां कहां पे है. गेटिंग माय पॉइंट? वो सब कुछ हाईलाइटेड आपको दिख रहा है. What red band is there? You are getting everything where red point is there or where red pixel is there. Apart from that, everything is in a single color. Fine. So this is a pseudo color image for you, where you are getting exactly that particular baseband where you are trying to filter it from the RGB color constituent. Fine. So we are filtering red channel out of it. So that's why red channel is getting focused out of it. Fine. So this was the program one student asked me to run, and it was not done on 7.5. But after getting it changed, this was the line. I again want to get your attention for this. This was the line where we have done the changes. Fine. जिस इमेज में चेंज करना है उस इमेज को जिस अपने वेरिएबल में आपने स्टोर कराया है, उसके बाद कोलन कोलन और 1 देते हैं ताकि रेड बैंड को करेगा. फिर अगर ब्लू देंगे तो ग्रीन बैंड को करेगा. एंड दिस इज वन ऑफ द एग्जांपल. अपार्ट फ्रॉम दैट, इफ यू वांट टू से कि इसमें अगर मान लो अपन ऑटोमेशन करना चाहें तो कैसे होगा. अगर मान लो हम कुछ ऐसा करें जिसमें एक कलर के इमेज के अंदर दूसरा इमेज जो है हम इम्बेड कर दें, या फिर एक इमेज के अंदर से हम दूसरा इमेज जो है वो बाहर निकाल लें. ठीक है. सो देयर इज अ कंसेप्ट. मैं अभी आपके साथ डिस्कस करता हूं. बहुत शॉर्टली में करना पड़ेगा क्योंकि वी आर रनिंग शॉर्ट ऑफ टाइम. सो दिस इज अ कंसेप्ट. आप इसको देखना, इससे इम्बेड भी सीख जाओगे और एक्सट्रैक्शन भी सीख जाओगे. ठीक है. अगर मान लो अपने को यहाँ पे इमेज को वाटरमार्क करना है, उस पे DWT आप लोगों ने पढ़ा होगा, यानी कि डिस्क्रीट वेबलेट ट्रांसफॉर्म. उसको यूज करके आपको जो है उसको वाटरमार्क करना है. उसको वाटरमार्क करने के बाद उसमें से जो है ओरिजिनल इमेज जो है वो एक्सट्रैक्ट करना है. फॉर दैट यू हैव टू यूज अ एल्गोरिथम कॉल्ड हार ट्रांसफॉर्म. फाइन. सो यू जस्ट नीड टू पास द थिंग हार. ये वाला लाइन देखो, मैंने इसको येलो हाईलाइट किया है. When you are using this point, you are getting DWT2. I mean, you are applying discrete wavelet transform to some image with hard transform into it. Fine. So once you are making it watermarked, then you are extracting that watermark image from that particular line. Getting my point? पहले आप एक इमेज के अंदर जो है उसको वाटरमार्क कर देते हो और फिर उसमें से इमेज को वापस एक्सट्रैक्ट कर लेते हो. तो पहले वाले में आपको वाटरमार्क करना पड़ेगा, DWT करना पड़ेगा, और दूसरे वाले में आपको करना पड़ेगा IDWT. देखो सिंपल कंसेप्ट है. पहले वाले में आपको DWT करना पड़ा, डिस्क्रीट वेवलेट ट्रांसफॉर्म को अप्लाई करना पड़ा पर्टिकुलरली उस इमेज में. दूसरे वाले में आपको इनवर्स DWT करना पड़ा, यानी उसका जस्ट उल्टा. जैसे कि अपन डू और अनडू करते हैं ना, जस्ट इन द सेम वे. फाइन. एंड वी हैव टू यूज हार्ड ट्रांसफॉर्म इन द बोथ केस. फाइन. So we have to go through with hard transform. Now what hard transform is doing, it's not possible to explain you in a very short span of time. So we will have some long classes, descriptive classes, then we can discuss from A to Z everything. Fine. So what we are doing here, जो मैं यहाँ पे आपको बताऊंगा वो ये concept है जिसमें अभी आप इसको अच्छे से समझ सकते हो. You can see here in a red line, it's width LL. Fine. It's width LL, LH, HL or HH. Yani horizontal, horizontal, L for left, 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 horizontal, horizontal, left, and horizontal, horizontal. Fine. So when you are capturing some image, so उसके किस पार्ट पे आपको DWT अप्लाई करना है वो आप इस इनबिल्ट फंक्शन से बताते हो. So whenever you are writing this, it means left horizontal, left vertical. Fine, if you are using left vertical. Similarly, there horizontal left left. तो जब आपने DWT करा तब आपने ये कंसेप्ट यूज करा था. Horizontal left left, horizontal left, horizontal, horizontal, horizontal left, and so on. Fine. But the common thing is we have to use hard transform and we have to use DWT. Fine. Now I'm going to run it. So if this is a program we are having, so we need to have, 3 or 4 images. I'm just telling you. So first image is host.jpg, basic image. Then you want to get watermark on some particular image. So there is a watermarked image in a data set. Then what watermarked image you have made, it is generated in another output. So it will be termed as watermarked.jpg. It will create another image by the command called imwrite. जैसे आप imread से input कराते हो ना, वैसे ही आप imwrite से किसी भी jpg image को png में convert कर सकते हो, png को bmp में convert कर सकते हो, and so on. Fine, you can write your own image in your own way. So whatever watermark algorithm you are performing, whether it is discrete wavelet transform or anything, so whenever you are performing it, it will generate some output image. So that particular output image will be an input image in the very next step, what we are showing here. Fine. So it will generate it by itself only. And then finally, we need extracted watermark image. Fine. So extracted watermark image जो है वो हम यूज करेंगे और फाइनली हमारा जो इमेज है वो एक्सट्रैक्ट होके आएगा. सो वी विल हैव 4 or 5 विंडोज ओपन फॉर दिस पर्टिकुलर प्रोग्राम. सो आई जस्ट नीड टू रन इट and you can see we are having 7 outputs. So let's discuss it one by one. So in a very quick manner. So there is a original image. Then what we have performed, DWT on a particular part of that image. अगर आप यहाँ चाहते तो आप डेटा सेट के अंदर से 2000 नोट्स भी ले सकते हो, उस पे भी किया हुआ है काम हमने, तो आप उस पे भी अप्लाई कर सकते हो within some certain domain or some specific part. Fine. Then there is a third point is what we have done, watermarked image. So we have taken this watermarked image जिसके अंदर पहले से जो है एक इमेज या फिर कुछ जो टेक्स्ट है वो इंस्टॉल है. Fine. Then we have applied DWT on that particular watermarked image. You can see it. Getting my point? So this is applied DWT on particular domain of watermarked image. Now what we will do, we will see the changes. This is what we have done. We have pasted or we have embedded one image into other image. Fine. उसमें हमने उसको embed कर दिया. You can see a strawberry shadow in the vegetable part. Fine. And now हमने इसमें वापस IWT वापस डाल दिया. क्यों? क्योंकि हमारे को जो इमेज हमने इम्बेड करा है उसको फिर बाहर एक्सट्रैक्ट करना है. ठीक है, तो ये क्या हो गया, DWT of watermarked image. Fine. Now the final part is what we have performed, extracted image. Now we are getting the same image what we have done before. So we are getting the final extracted image. So image को image में embed करना और फिर उसको extract करना. So it is very much possible in currency watermarking. It is very much possible in making those currency, making those notes very much safe and secured. So this is one of the examples. So let's finish it and move to the next one. Fine. Then there is a program which is for embed करना सिर्फ. ठीक है, आपको सिर्फ वाटरमार्क करना है, जो कि हमने पहले वाले प्रोग्राम में भी किया था. ठीक है, तो कंसेप्ट आप देख सकते हो आपके स्क्रीन पे है, बिल्कुल सेम, नथिंग हैज बीन चेंज्ड. इसमें सिर्फ वाटरमार्क्ड होगा. आई एम गोइंग टू रन इट. फाइन. तो इसमें एक्सट्रैक्शन बस हमने परफॉर्म नहीं किया है, बाकी सब कुछ वैसा ही है. ओरिजिनल इमेज, DWT we have performed. Then we are having watermark image. then we are having DWT on watermark image, and then we have final watermarked image. तो इसमें हमने extract नहीं किया, इसमें you can see the strawberry shadow is there in the vegetable part, so it has not been extracted. So एक step इसमें हमने कम किया है, बाकी सब कुछ same है, ठीक है? So this is one of the example. Apart from this, I'll show you something else. जो basic programs हैं, उसमें मैं आपको कुछ दिखाता हूँ. When we are doing this, why we are using Matlab and what is the point of getting it automated? See how much extensive calculation we have done. ये manually possible नहीं था, समझ रहे हो? एक feature vector को उसने calculate करा है, which is not possible manually or I mean any simpler tool. So it is a very extensive calculation tool. Right from we are having calculation from 200 columns, from 224 columns. Fine. So you can see the calculations. You can see the matrix structure. Why it is very much required, why it is very much needful. This is the a strong point of AI or a strong point of automation tool or a strong point of simulator. Fine. So let's discuss other example as well. I'm going to discuss with you one perfect example that how these things I'm getting happened. Fine. So this is a program we are having, fine. And on what image we are going to perform it, I'm just telling you what we will do. ये हमारा image है, तो इस पे जो हम detect करेंगे इस image को, वो हम ऐसे detect करेंगे कि जो इसका dynamic threshold है, वो हमने पहले से ही set कर रखा है by, of course, by using hit and trial and dynamic thresholding equation. हमने इसमें उस दिन आपको जैसे मैंने बताया था बाउंडिंग बॉक्स एल्गोरिथम यूज किया है, वो हमने यहाँ पे भी यूज किया है, बट इट इज बेस्ड ऑन डायनेमिक थ्रेशोल्ड टेक्नोलॉजी. फाइन. और इसमें जो है हमारे को अपने आप पता चल जाएगा कि जो डायमेंशन है या फिर जो आपका डोमेन है आपके ऑब्जेक्ट का, वो इस ब्लैंक पिक्चर में कहाँ पे है, एंड इट विल डिटेक्ट इट डायनेमिकली, और ये आपको अभी शो भी हो जाएगा. फाइन. यू विल हैव टू वॉच इट. Then we will discuss the code and everything with you. Fine. So just see, this is the code we are having. You just have to watch that what it is getting done, and ये कैसे हुआ वो मैं आपको इसके बाद बताता हूँ. Fine. So this is the code for just image resize, and we have just input the loading the image. That monkey.png has been loaded into the Matlab. Then we have done the initialization part. ये वाला जो line है जिसको मैंने select करा है, it is for segmentation. It is for dynamic threshold. Fine. So we have set that segmentation from 400. You can do it from 300, 200, 350. What we have got on 400 is the best example we are having. Fine. So now we will run this program. So this is the program we are having, and we are going to run it, change directory. So you can see this, and you can analyze this how this iterations, number of iterations is getting done, and how it will detect that particular image. It is getting automated. I'm not doing anything apart from making that program. So Matlab has given us so much reliability and so much of the things. So finally, initialization has been done and final segmentation has been done. So you can see it can be done in surveillance. It can be done in any death cases or any murder cases whenever forensic department need to get some evidence or something. So it is very much important. So we have done this in 400 citation, but what we are doing here, if we are getting it changed into 300, iteration can be 300. Fine, I'm saving it, and I'm just clearing this image out of it, and let's run it. You're getting iteration is still going on. but the case is for optimization. The case is for efficiency. Fine. So it will be, stopped after 300 iteration, and what we will get after 300. See, we are not getting the optimum result. Fine. You can see the third image. Fine. Subplotting of the third image, we are not getting the right result. Fine. So let's do 350 over here. What we are doing, we have just increased 350. Whether it is optimized now, so we just need to run the image. Fine. So it will be run for 350 iterations. Now we will see what optimization we are getting now, if it is visible to all of you. See, even though, if you can see at the left side where I am moving the cursor, this has not been captured. This has not been captured. Getting my point? So some domain still remain left. That's why we have used 400 by hit and trial method. If you are using it 90, even though I have got some issues, fine. You can see here, it will do 390 iterations. So it will also make a difference. The difference will be, minimized, but it is not as dynamic as it was on 400. That's why I set the value of threshold at 400 only. Fine. So it will stop over here on 390. Even though where I am moving my cursor is, you can see this domain has been left. Fine. So what we need to do, we just need to make it 400 or just make it 405 and see what happens. Now it will go for 405 iterations. Fine. So this is a MTech project which has been done from my student. So, and it has been recognized by some good publishers as well. So this is 405. So it will cover some extra effort. It is going much more into it, but it's okay. 400 is also fine. Fine. So I have fixed it on 400 and now we are checking it for 400. Fine. So it's fine. So let's move to the next example. I'm just telling you what segmentation is all about, what initialization filtration is all about, and what is dynamic threshold is all about. Why we are doing this, how automation can be achieved by dynamic things. Fine. So even if we are doing some recognition or moving a object recognition or some threshold thing, we are supposed to have something which has been based on some dynamic values, not on some static values, जिसको एक बार आपने change करा तो आपको बार बार करना पड़ रहा है. ठीक है? So this is one of the concept. Apart from this, we are also getting some calculation over it. So localization radius has been come every time we are doing this. So this radius has been calculated by automated method. Fine. So let's move toward the next example. I have just discussed about the format change. अगर आप मान लो किसी JPG image को आप बताना चाह रहे हो कि हम इसको इस image को किसी और image में लिखना चाह रहे हैं, तो आप क्या करोगे? Fine. So this is a very simple program for this. You need to take info of that particular image. Fine. So you can take here onion.png, which has been there only. Onion.png. Fine. Now you are taking onion.png. Fine. आपने उस इमेज का इन्फो निकाल लिया. इन्फो से आपको पता चल जाता है कि इमेज में क्या क्या कोऑर्डिनेट्स हैं, किस कोऑर्डिनेट्स पे कितनी पिक्सल वैल्यूज है. This is simple. There are 2-line program. Then you have to subplot it. Now, what is the concept of I write? So whenever we are writing I write, we have to use the input image you want to change the thing is. Then you have to write it onion.tiff. Fine. So whatever the format you are changing it to, it should be written in single inverted comma, which is TIF. Fine. So you are changing that particular PNG from PNG to TIF and you are subplotting it, ठीक है, और जो J है उसको आप I के बराबर कर रहे हो और शो कर रहे हो किसको, J को, ठीक है, and then what is J? J is जिसके अंदर आप I write डाल रहे हो, ठीक है. So now run this program, add to path, getting this point. पहला वाला जो है वो onion.png है which has been done और दूसरा वाला जो है वो TIF में है. तो ऐसे कुछ आपको ज्यादा इसमें differences पता नहीं चलेगा, but you can change the format of particular image by doing so. IM write image का नाम, the format in which it has to be changed should be written in single bracket. So this is one of the example. Apart from this, if you want to dilate some image, fine. और किसी image का difference निकाल रहे हो, ठीक है. मान लो हमने कोई दो इमेज लिया और उसका डिफरेंस निकालना कि इसमें क्या क्या डिफरेंस है. सो वी हैव टू टेक सम इमेज व्हिच हैज बीन हियर ओनली. सो इट इज onion.png, fine, and we have to take some other image if it is needed. If it is not needed, color map अभी आपको मैंने बता दिया क्यों यूज होता है. IM dilate और IM erode. So erosion और dilation, these are the two things which need to be discussed. जो कि आपका वहां यूज हुआ था जब आपने कार प्लेट का नंबर रिकॉग्निशन किया था, तो इरोजन और डायलेशन यूज हुआ था. टू इरोज मतलब टू इरोज द थिंग which is not needed, to dilate the things which is need to be focused. Fine. So there are two concepts, image dilation and image erosion. Fine. So we have to use that and just perform this program and we can get the difference of the image. So पहला वाला देखो आप dilated image है, इसमें हमने जो है वो इंडेक्सेस भी भर दिए थे, तो इसका इंडेक्स पे भी ये प्लॉट हो गया है. दूसरा वाला जो है वो इरोडेड इमेज है एंड यू हैव टू यूज जस्ट IM dilate and IM erode, that's it. Apart from that you need to do nothing. You have to perform this command by passing some parameters you wish to have and then you can find the difference. So what we did basically is we have done dilation. So आप dilation से ये समझ लो कि जो मैक्सिमम उसका जो पिक्सल इंटेंसिटी होता है ना वो डायलेशन से आ जाता है और जो मिनिमम से होता है वो इरोजन से होता है. और जब आप ग्रेडियंट निकालोगे डिफरेंस, सो मैक्सिमम माइनस मिनिमम का होगा. फाइन. तो वो आपको पर्टिकुलरली डिफरेंस आ जाएगा. देन वी आर यूजिंग STREL मतलब स्ट्रक्चरल एलिमेंट. आप किसी इमेज पे स्ट्रक्चर एलिमेंट अपन क्यों कर रहे हैं, इसको एक बार रन करा के बताता हूं. इसमें हम स्ट्रक्चर एलिमेंट इसलिए कर रहे हैं कि मान लो इस इमेज के किसी खास पार्ट पे ही आप इरोजन और डायलेशन लगाना चाह रहे हो, सो दैट पर्टिकुलर पार्ट विल बी फोकस्ड through the Matlab tool or any tool OpenCV you are using, and then we can get the A maximum by using dilation. Then we are getting erosion, I mean minimum resolution intensity, and then we are getting difference by differentiating between A maximum and A minimum. Fine. So there are lots of other concepts which need time to discuss with you. अभी टाइम थोड़ा कम है, तो अभी बहुत सारी चीजें हैं जो हम डिस्कस कर सकते हैं, इसका पूरा कोर्स कर सकते हैं. अपार्ट फ्रॉम दैट, मान लो इमेज आपको एडजस्ट करना है, उसके लिए एक छोटा सा है कि मान लो कि आपको कैमरामैन टिफ जो है वो आपको किसी खास पॉइंट पे एडजस्ट करना है, जिसकी इमेज की डेंसिटी होगी पहले वाले एक्स कोऑर्डिनेट की 0 से 0.2. इट कुड बी लाइक 3. इट इज हिट एंड ट्रायल मेथड. और इसकी 0.5 मैक्सिमम हो सकता है. 0.5 इमेज डेंसिटी, उससे ज्यादा नहीं हो सकता. इमेज जो है वो उसका रेजोल्यूशन जो है वो स्कैटर्ड हो जाएगा, है ना. तो इसको अगर अपन रन कराएं, सी वी हैव डन सम इमेज एडजस्टमेंट एंड व्हाट पॉइंट इट हैज बीन डन. इसको थोड़ा चेंज करके देखो तो इट विल बी मच मोर क्लियर. तो मैंने यहाँ 2 पे किया था तो ये ज्यादा क्लियर आ रहा था. Now you can see there is a very much less difference. So you can adjust your image as well. You can make the negative of that particular colorful image as well. Fine. So there are lots of such concept, a small and big program which can be done. Fine. So image अगर आपको noise removal करना है या population bar graph बनाना है, it is not, MATLAB is not limited to any इमेज थिंग ओनली. इट इज नॉट फॉर इमेज प्रोसेसिंग. यहाँ पे क्या होता है, आप मैकेनिकल का भी काम कर सकते हो, सिविल का भी काम कर सकते हो, ऑटोकैड भी कर सकते हो, एवरीथिंग यू कैन डू. न्यूरल नेटवर्क का अलग टूल आता है, मशीन लर्निंग का अलग टूल आता है. सो इट इज अ वेरी वास्ट टूल, इट इज अ वेरी वास्ट सिमुलेटर. जिसमें आप अपने हिसाब से अपने फंक्शंस जो है वो लिख सकते हो और उनसे आप एल्गोरिदम बना सकते हो. फाइन. इवन इफ यू आर आई मीन सपोज टू हैव सम डायनेमिक ग्राफ्स और समथिंग, तो आप वो पॉपुलेशन ग्राफ भी ऐसे बना सकते हो. तो जहां क्लिक करोगे वहां वो चीजें आती जाएंगी. और इसमें हमको कुछ ज्यादा नहीं करना पड़ा, हमारे को 3 या 4 लाइन का कोड लिखना पड़ा है. यू कैन सी इट हेयर. फाइन. और एक लूप लगा दिया हमने 1 से लेके 3 तक. 1 से लेके 3 तक इसलिए लगाया फॉर एशिया, साउथ अफ्रीका एंड नॉर्थ अमेरिका, ऐसे. तो पॉपुलेशन ऑफ द कॉन्टिनेंट का हमने एक वर्ल्ड पॉपुलेशन 2006 का बनाया. फाइन. So there are lots of other example you can have. So if you are interested, so we can discuss it. I'll share some other classes links with you with Himanshu sir, so he will discuss it with you. Apart from that, if you want to add noise or remove noise, so we just need to im noise. Fine. And if we have to remove that noise, we just have to use winner filter. Fine. So you can see this. Fine. So we are having one noise. We are having one picture which is the original image. और उसके बाद हमने उसमें Gaussian noise थोड़ा सा डाल दिया है. वो मैंने आपको उस दिन करके दिखाया था. So this is a image which is having Gaussian noise. अब इसमें से चीजें अगर मान लो हटाना है, तो if we will have some discussion over IWT, fine. Inverse अगर हम कर देते हैं, तो वो फिर क्या करता है, उस इमेज को एक्सट्रैक्ट करके आपको वापस दे देता है. Fine. So if you will have that, everything is available on Matlab tool. Mathswork में आपको जाना है, and you can have learn. You have to go on product help. Fine. And then you can start the things. अभी सर ने जैसे aerospace toolbox बोला था, तो ये aerospace toolbox भी आपको यहीं मिल जाएगा. You need not to go anywhere else. Fine. अगर आपको मान लो इमेज पे जाना है, तो you should type here image. जेनेटिक एल्गोरिदम पे जाना है तो डिमेज. अब ये देखो जेनेटिक एल्गोरिदम है, यहां से आप जो है इमेज एक्विजिशन, इमेज प्रोसेसिंग का सारा प्रोग्राम मिल सकता है आपको. फाइन. तो आपको बेसिक्स नॉलेज यहां से हो जाएगा. सारे कमांड्स यहां पे अवेलेबल हैं. फाइन. आपको जान लो मैट्रिक्स एडिशन सब्सट्रैक्शन पे जाना है, यू हैव टू स्टार्ट फ्रॉम बिगिनिंग. फाइन. सो हियर इज द एग्जांपल वी आर हैविंग. ठीक है. आप इसके लिए इमेज एक्विजिशन डिवाइस आपको अलग से इंस्टॉल करना पड़ेगा. उसके बाद आप ये प्रोग्राम जो है, यू जस्ट नीड टू कॉपी एंड पेस्ट इट, एंड यू जस्ट नीड टू हैव दिस टूल इनटू योर सिस्टम. तो आप वीडियो का प्रोग्राम भी चला सकते हो, बट उसको कहां पे चलाओगे आप? 2019 वाले वर्जन पे. देख रहे हो? सो यू विल गेट एवरीथिंग व्हाट एवर यू नीड इन द प्रोडक्ट हेल्प. कहां जाना है अपने को? हेल्प में जाना है. उसके अंदर प्रोडक्ट हेल्प F1, और उसके अंदर आपको जो भी सर्च करना है, जो भी चाहिए, वो आप यहां से ले सकते हो. रियल टाइम वर्कशॉप इज देयर. फाइन. यू कैन हैव एवरीथिंग ओवर हियर. फाइन. सम बेसिक कांसेप्ट्स. ये देखो, आई एम इमेज को रीड करना. जो मैं आपको pout.tif बताता हूँ वो यही है. ये ऑलरेडी अवेलेबल है इसमें. cameraman.tif यही है. इस पे हिस्टोग्राम कैसे जनरेट करें, एवरीथिंग इज अवेलेबल. इमेज की इन्फो कैसे चेक करें, IM इन्फो जब आप करोगे तो ये अपने आप जो है ये सारा डिटेल आ जाता है. So you just need to copy and paste it. See this. I'm just copying it and I'm just getting it pasted. I'm just doing this for raising your interest. Fine. अब ये image info क्यों नहीं दिया? क्योंकि ये pout2.tif है ना, ये अवेलेबल नहीं है. तो pout.tif जरूर अवेलेबल है, ये जरूर दे देगा, है ना. वो जो इमेज है वो अवेलेबल नहीं था. ये देखो, इस इमेज का सारा डेटा हमारे पास आ गया. Fine. I have done nothing. I have just taken it, copied it, and pasted it. Fine. So you have to go through with all the things from help only. Fine. Advanced topic भी मिल जाएगा आपको कि read and display image. Background pixel अगर आप अलग करना चाहते हो, ये देखो चावल के दाने हैं. अब इसमें अगर आप background pixel अलग करोगे तो ये सब अलग हो जाएगा, और चावल के दाने जो हैं वो अलग हो जाएंगे, और background pixel अलग हो जाएगा. So there are lots of other examples, and you just need to copy it and paste it. You have to check it. Fine. So apart from that, if you are having any issue, you can contact me directly also. Any question is there? I would love to answer if there is any question, because this is the last session. I luckily have to get it. So should I continue, sir, or we are having short of time?
So as you wish, we take a question if your permission is granted.
Yeah. Please. I mean, if there is a question, I would love to
One of
answer.
the participant asking the question that I don't know, it is related to the you or Sreenatha sir. Explain how we can compute the time complexity of the.
Vedant is asking how when we compute the time complexity of basic fuzzy. Yeah, this is for Sreenatha sir.
Yeah.
But basically we can do it just like what we did in data structure. So what you have done in data structure, you have to program for that in Matlab or in C or in C++, and you can get the time complexity for that particular program. So जितने लाइन का प्रोग्राम होगा या जितना टाइम वो लगाएगा चलाने में, जैसे मान लो कि आप ओरेकल का भी प्रोग्राम कर रहे हो और ओरेकल का प्रोग्राम जब आप रन करते हो तो जब क्वेरी रन करते हो तो आता है ना उसमें 1.1 सेकंड 2.5 सेकंड या फिर 0.0 सेकंड 0.5 सेकंड. तो that is the complexity of the program. So whatever the complexity, it will come automatically out of it. So whatever the algorithm you are typing or whatever the algorithm function you are making, that will decide what would be the time complexity of that program. तो अभी जैसे आपको मैंने ये दिखाया था ना, मैंने मैटलब टूल बंद कर दिया कि जैसे मान लो 18 पिक्सल आते हैं या उसके फीचर वेक्टर आते हैं, तो जिसका फीचर वेक्टर ज्यादा होगा उसको रन करने में कॉम्प्लेक्सिटी ऑब्वियसली ज्यादा लगेगी. सो इट विल कम ऑटोमेटिकली. वी ऑल हैविंग आई मीन इनबिल्ट फंक्शन फॉर दैट इन मैटलैब. अपार्ट फ्रॉम मैटलैब, आई मीन देयर इज अनदर क्वेश्चन.
Can we have direct command in MATLAB to implement artificial neural network?
Direct command we do have, Aarti ma'am, but we have to type our function by our own, because see, if the version is getting differentiate, the same program will not run in the different version. Suppose I'm making a program in 7.5 and I'm sending you, you cannot copy paste into 2013 version and it will get run. Getting my point? So you have to get a student version or trial version of neural network tool of MATLAB, and you have to install it to get the program. Apart from that, if you will type NN and just make type enter out of it, so you will get neural network tool open, but it will not run any program out of it, ma'am. So you have to install it. Yeah.
Thank you. Professor Abhishek, I have from my side question.
Yes, sir.
MATLAB is also very vast and very expensive software. So from where we will get and from which software the participant or the scholar will work freely? MATLAB.
Sir, MATLAB, I'm also using trial version only. Getting my point? But in our university, they are having the original version as well. Fine. In all labs, they are having original version, but it is very much costly. So I do have some links like filehypo.com or Exopedia or something. So there are lots of things. I do have version of 2018 with cracking code, but being a resource person, I cannot say this because it is illegal to use. So on record, we cannot say that to encourage such kind of thing. But we do have some many options to use MATLAB, all tool. I mean, legally you have to use online browser version by your email ID for 1 month, and then you can use another email ID. So you can use that, or you can download it also. So you will get 2020 version as well for free for 1 month.
Okay.
Yeah.
So thank you for
sir.
Idea. Then how we can get this MATLAB and how we can use and code out our own. So it was an interactive session, Dr. Abhishek, because
Thank you, sir.
my on topic in my MTech was also image processing.
Yes, sir.
And I know that you helped very much on that. So also the other participants in this STTP also getting the knowledge deeperly inside the image processing using.
I must want to confess one thing. MATLAB was firstly introduced by Himanshu sir to me. We were living in the same room and he introduced that MATLAB. I like the tool and I'm teaching it for 5 years now.
Yeah, so it depends on your expertise and your
interest is the thing.
Because you are now become we can say father of this programming, and
nothing like that, sir. Nothing like that. I'm just sharing what things I have been done.
So it's one great pleasure always with interact with you and feel us very proud, and we can say